My name is Wissam Khosrow.
I'm Caleb Hoka. I'm Alan Sawala. We're Team White Walkers, and we did the audio sampling project.
My section was the editing section, so I did cool features like sound reversal, tone control, filtering, and noise removal.
I did the user interface section, so what's shown on here, the grid, and the functionalities behind that.
I did the basic tone generator or the synthesizer, which is this part right here, where I just basically use a sine wave with other different waves to play different sounds.
So let's start it. So to begin, you click the grid option menu, go to the audio files selection, add new file. A window will pop up where you could choose any file you want. So let's choose drum hit. Then you can click to choose which button you want it to be playing on. And when you click that button, the sound plays. You can also use the keyboard. So I'm pressing the Q key right now, and it's playing the same file. You could do it for multiple files. So let's try drum hit 2 on key W. So when you play it, and then using the keys. So if we add many files on, say, A, now we can clear the files. You could choose clear all, clear row, or clear column. So for clear row, let's say we clear row 1, that should be Q and W. And as you can see, when I click on them, there's nothing, but when I click A, it still plays the audio file. Clear all. Now everything does not have a file associated with it. And that's basically what it does. Let's get into the code. So if I open the code, we use App Designer to design everything in the UI. Here, I declared many variables, the button, sound files, the key numbers, sample frequency, everything up in the properties section so that it could be transmitted to every function of the app. So here's the import file. First, use the UI get file function to select an audio file and save it to file name. You take that file name and you read it, audio read it, into two separate variables, the Y sound and sample frequency. As you can see, it's of app, so it's transmitted through every function. Then you do a choose button function, which basically pops the menu up where you choose which button to select for the audio file. And it saves the array of the file, this audio file, and the frequency so that it could be used later when you press the button. This is not my section. Here's the key press. It's basically you press which key it is, it plays the sound associated with that key. Here's a clear row. So case 1 is row 1, which is 1, 2, 3, button 1, 2, 3. 2 is 4, 5, 6, so on. Clear column is the same thing, but for columns 1, 4, 7, 2, 5, 8, 3, 6, 9. And here's the button press. You just use sound, the Y array, and the frequency to sound each button. Now I'll turn it over for the editing.
Alright, this is going to be my section. So for the edit, we're going to go to the edit existing file. We have the sound removal, the sound delay, the tone control, the change of speed, the noise removal, and for this part, the trim audio. We worked, me and Caleb, on this part together. I'm going to start with the sound reversal. So we're going to choose a file, drum hit, open, choose a key. Okay. audio files, edit, sound delay, drum hit 2, open. See that delay right there? The sound delay was tone control. We have the low pass and the high pass. We'll get into the code in a second. Do you have a longer sound? Yeah, dog scratch. We have the low pass filter and the high pass filter. That was the low pass filter. This is the high pass filter. Now, the change of speed, I added 3 options to the speed. It can play half the normal speed, it can play 50% faster than the normal speed, and 100% faster, 2 times faster than the normal speed. Let's try 1.5%, 50%. Q. Let's try. Oh. Cancel. Let's try 2%, 200 times 2, 100% extra. Q. It's really fast there. Edit. The last section I did on my own was the noise removal. So basically what it does, it removes the noises that might happen, like whooshing sounds, when the sound file is silent. So it removes all the unwanted noises in the silence. That was it. Now let's get into the code. Let's see right here. Alright. So if no option was chosen at first, it will just play the normal sound, nothing edited. If the first option was chosen right here, which is the reversal loop, basically what I did is manipulate the matrix to play from the end -1 all the way to the end divided by 2. This was also, I did this with the help of Caleb, who was playing twice, so gotta give him credit for that. The delay option right here. So basically what I did is use the convolution function right here. The convolution function uses vector arrays, so I had to index the Y sound array right here and use the convolution function and play at the sample frequency. Now to the tone control, I used the butter function, the filter function, to do the low pass and the high pass. And for part 4, which is changing the speed, it's pretty simple. We can do this multiple ways. We can play every other element of an array, or we could just do what I did right here, is multiply the frequency by 0.5, 1.5, or 2. And the last part that I did on my own was the noise removal. I did this by defining the frame duration, the frame size, by rounding the frame duration times the sample frequency, taking the length of Y sound, and then IDing the maximum for each frame, and then setting a threshold that is the 0.03 right here, setting that as the maximum, and then eliminating all the other frames that are lower than this threshold, and that will eliminate the noise during the silence. And this part 6, this is what we did together.
So for the cutting function, it works. You go to audio files, edit existing, trim audio. You could choose a long file. See, this one is about 25 seconds. So if you open it, so it says it's about 25 seconds, so you have a frame of reference. It indicates the start time, so you start at 20 seconds. Choose button Q. It plays the last 5 seconds of the file. The way it works is we basically got the number of samples per second based on the frequency. We found the time by multiplying the length of the entire file by the number of samples per second to get the amount of seconds it was. It creates a menu that tells you the time and creates an input dialog box where you could select the start time. And the way it works is you change the beginning to be the start time times the number of samples per second, so you could get the location of the array at that specific second until the end. Unfortunately, we weren't able to find how to cut the sample from the end, no matter what we did, but we got the start part.
Okay, so for what I did was the synthesizer, and I'll keep it short for the sake of time. It was this, yeah, this is the correct one. Yeah, let's see. So to begin with, I declared the variables and changed them with the help of my partner here, and then we just implemented the callback functions to be able to use this basically. So to show that it works, I'm just gonna put in different. Yeah, so this shows that it's working, and then to show that your sound, that's with the square wave, sine wave, the sawtooth, and the triangle. Then we can test it how it would sound different with other. Let's see. Just put 900. With different frequency and amplitude, and I would say that is it.
Okay. Thank you for listening, and we're Team White Walkers.
Thank you.
Let's see how long it was.
I noticed that it was going